Okay, so in this video, we are going to talk about differentiation of trigonometric functions. Now, before we start, we have to know the derivatives of some of the basic trig functions. So let's start with this table. We have the function here and its derivative here. So the derivative of sine x is cos x. The derivative of cos x is negative sine x. The derivative of tan x is sec squared x. The derivative of sec x is sec x tan x. The derivative of cot x, that's cotangent of x, is negative cosec squared x. And the derivative of cosec x is negative cosec x cotangent x. So that is the derivative of the basic trigonometric functions. Now let's get into the more interesting part. Now when we have a trig function, let's say y equals sine ax, like this, you have to find y prime, or the derivative of y with respect to x. All that you have to do is to differentiate whatever that is in the bracket here. That's the angle. You have to differentiate the angle. The angle will probably be a function of x or something, the independent variable, a function of the independent variable. So you first of all differentiate that. So when you differentiate ax, you're going to get what? A, because a is a constant. Then after differentiating the angle, then you differentiate the trig function. So here when we differentiate sine ax, you will get cos ax. So that's how trig functions are being differentiated. Let's take another example. When we have maybe y equals, let's say cos as squared plus bx plus c, where a, b, and c are constants. You have to take the derivative of y with respect to x. Like I said, all that you have to do is to first of all differentiate the angle. Here the angle is a function of x, right? That's as squared plus bx plus c. So you differentiate whatever that it is in the bracket, or whatever that the angle is. After differentiating, then you differentiate the function, the trig function, and multiply by the derivative of the angle that you had. So here we are going to just get, when you differentiate as squared, we will get 2ax. When we differentiate bx, we will get b. When we differentiate c, constant, so it will go to 0. So this multiplying, when we differentiate cos, we get negative sign. So negative sign, everything in the bracket again, plus bx plus c. So at the end of the day, y prime is going to be negative 2ax plus b multiplying sine as squared plus bx plus c. So that is that. So in differentiating trig functions, you have to first of all differentiate the angle. Then you multiply the derivative of the angle by the derivative of the trig function. So in general, when we have a trig function, y equals sine of u, where u is a function of x. So u is a function of x. You have to find the derivative. So y prime is going to be u prime cos, because when we differentiate sine, we get cos, u prime cos u. So that's how it's going to be. So u prime, you differentiate the u, which is a function of x, then you what? You multiply it by the derivative of the trig function. So that's how it's going to be. So that's why initially we said sine x, its derivative is cos x, because the idea is here the angle is x, and when you differentiate x you get 1. When you differentiate sine x you get what? Cos x. So it's going to be the cos x. Okay, so let's start solving some real examples. We have y equals cos 3x squared. We asked to find dy over dx. Okay, so we have our function here. So dy over dx is going to be, you can pause the video and try. Yes, so we have 3x squared as the angle here. So we differentiate whatever that we have there. When you differentiate 3x squared, we are going to get what? 6x, right? Multiplied by the derivative of cos 3x squared. So you are going to get, if you differentiate cos, you get what? Negative sine. So we get negative sine 3x squared like this. So the derivative of cos 3x squared will be negative 6x sine 3x squared. Just like that, as simple as ABCD. Okay, let's take another example. Let's say we have let's say f of x equals cos x sine squared x. Okay, so how are we going to differentiate a function like this? So we just apply the what? We apply the product rule, right? Because you have a function of x multiplying a function of x here. So it's a product. So by definition, f prime of x is going to be, we will hold cos x, then we differentiate sine x. So cos x d over dx of what? Sine squared x. Sine squared x plus sine squared x, then d over dx of what? Cos x. So you hold cos x, we differentiate sine squared x, we hold sine squared x, and differentiate cos x, right? Okay, so now let's notice something here. We have sine squared x here, so you're going to differentiate sine squared x, but you have to know that sine squared x can also be written in the form sine x all squared. So we have to use the what? We have to use the quotient, the chain rule to differentiate sine x squared or sine squared x. So when you use the chain, we are going to get something like this. So let's just solve the derivative and see. So cos x, when we differentiate sine squared x, we will get 2, as a matter of fact, you're going to get negative 2, you get 2, positive 2. When we differentiate sine, we get cos. So cos x into bracket sine x like this, plus we hold sine squared x, then differentiate cos x, we get negative sine x. Okay, so f prime of x is going to be cos x multiplying 2 cos x sine x plus negative sine x sine squared x. So when we simplify, we are going to get 2 cos squared x sine x minus sine cubed x like this. Okay, so that's our final answer. Okay, let's take another example. Let's say y equals sec squared x. You're supposed to find y prime. Okay, so notice that y equals sec squared x can also be written as y equals sec x all squared. So with this, we can use the chain rule. So we can let our u to be sec x and our du over dx is going to be, what's the derivative of sec x? We are going to have sec x tan x. So our y is going to be u squared, because this is u, right? U is sec x. So dy over du will be equal to 2u like this. So if we want dy over dx, or y prime, is going to be dy over du multiplying du over dx. So dy over dx is going to be dy over du. We have 2u multiplying du over dx. This is du over dx. So sec x tan x. So let's do the substitution and put our u in here. We know that our u is sec x, so sec x multiplying sec x tan x is finally going to give us sec squared x tan x. Okay, so that is that. Let's try one more example. Let's say we have y equals cotangent of x all over sine x. Okay, so we have to find y prime. So what do we know about this? This is what the quotient rule. So we can apply the quotient rule of differentiation to just find the derivative. So we can let u equals cotangent of x. So our u prime is going to be, what's the u prime going to be? What's the derivative of cotangent of x? Cot x will give you negative cosec squared s. Yes. Then we let our v equals sine x. V prime will be equal to, when we differentiate sine x, we get what? Cos x, right? So we know that our y prime, or dy over dx, is going to be u prime v minus u v prime all over v squared. We have everything here. It's a matter of substituting. So we have dy over dx equals, what's our u prime? Our u prime is negative cosec squared x multiplied by the v. Our v is sine x minus our u. Our u is cot x. So cotangent of x multiplied by our v prime, which is what? Cos x. So all over v squared, which is sine x all squared. So our dy over dx is going to be negative sine x cosec squared x minus cot x cos x all over sine squared x. Yeah. So that is our final answer. Someone will choose to simplify further. That's at your own cost. As far as we are concerned, we leave this as our dy over dx. So that is that for the derivative of trig functions. Like we said earlier, on all that you have to do. Let's say this is our function sine x, and u is a function of x, which is the angle. all that you have to do is you differentiate the y prime will be equal to the derivative of the angle here, and you differentiate the whole function. So sine will give us what? Cos u. So that is a general formula. That's a general idea on how we differentiate trig functions. Okay. In this video, we are going to talk about the derivatives of, or the derivative of the natural log function and the Euler's number. So derivative of natural log and the e function. That's what we are going to talk about in this video. But let's talk about the natural log first. Okay. Generally, when we have a function in the form y equals natural log of, let's say, u, where u is a function of x, then dy over dx is going to be u prime over u, just like that. So what you do when you have a natural log is, you see, you are probably going to have natural log of a certain function or natural log of a certain expression. So make that expression equals u, then you differentiate that expression. So the derivative of that expression divided by that expression itself gives you the derivative of that whole function. So here, if y equals natural log of u and u is our function of x, dy over dx is going to be the derivative of u, which is a function of x over the u itself. So that's all. So let's start with an example. Let's say we have y equals natural log of x. We have to find dy over dx. So our u is what? X, right? Now our u prime is what? 1. So dy over dx is going to be u prime over what? U prime is what? 1. All over u is what? X. So 1 over x becomes our answer. That's why always the derivative of ln x is 1 over x. Okay, let's solve another example. Y equals natural log of, let's say, ax squared plus bx plus c, where a, b, and c are constants. So when you want to find the derivative of y with respect to x, your u is going to be ax squared plus bx plus c, right? Your u prime is going to be 2ax plus b. So your dy over dx of this whole function is going to be u prime over what? U, which equals, we have 2ax plus b all over what? U, which is ax squared plus bx plus c. So it is straightforward. All you have to know is to get your u, you differentiate your u, then you are good to go. Another example. Y equals natural log of sec x. How are you going to differentiate this? So our u is what? Sec x. Our u prime is what? When we differentiate sec x, we have sec x tan x, right? So our y prime or dy over dx is going to be u prime or what? U. What is u prime? Sec x tan x. What is u? Sec x. So sec x will take your sec x like this. So y prime is going to be tan x. So the derivative of the natural log of sec x is what? Tan x. Okay. Let's take one more example. When we have f of x equals natural log of x squared. So natural log of x squared. So what will be your u? Your u will be what? Natural log of x squared, right? And your u prime will be what? You differentiate this 2x all over what? X squared, because it's u prime over u. It is a natural log, which natural log function and natural log function. So we differentiate the x squared to get 2x all over the x squared like this. Okay, so we can get 2 over what? Let's say x, 2 over x. because this x will take care of 1x here to get 2 over x. So our f prime of x is going to be u prime over u, which equals, what is our u prime? Our u prime is 2 over x all over, what is our u? Our u is our ln s squared. So that is that. You can further simplify to get 2 over x times 1 over ln s squared to get 2 over x ln s squared as our final answer. Okay, so the next one is the derivative of the Euler's number or the e function, like this. This is the Euler's number or the e function. Okay, so generally when we have y equals, let's say, e to maybe to the power u, where u is a function of x, dy over dx is simply going to be u prime multiplying e to the power u. So all that you have to do is to differentiate the power and multiply it by the function itself. As simple as that. So for example, when you have y equals e to the power x, our u is what? Our x. Our u prime is 1, right? Because when you differentiate x, we get 1. So our dy over dx is going to be u prime, which is 1, multiplying e to the power what? X. So we get e to the power of x, right? Okay. Again, let's take an example like this. Y equals e to the power x squared. Then dy over dx is going to be what? You can pause and try. Simply 2x e to the power what? X squared. So it's pretty much straightforward. So just get the understanding of the general formula y, which equals e to the power u. The y prime will be equal to, where u is a function of x, so it will be u prime e to the power u, right? So that is that.